Carbon, as it turns out, is much of the focus of organic chemistry. I'm sure you've all heard us refer to as carbon-based life forms. Okay? The definition of organic chemistry at times was as simple as saying it's the chemistry of carbon. The definition of organic chemistry, folks, is so blurred right now that I've taken that part of this course out of it. Because you see, back in the olden days, they said organic chemistry was the chemistry of everything that was taking place inside of living things. Inorganic chemistry was the stuff that was taking place of things that were never alive. So the chemistry of rocks, minerals, metals, well, we called those inorganic. The chemistry that was taking place like within your blood, the proteins, the carbohydrates, okay, we said that that was organic. Now, has anybody here been to a health food store recently? Some people, you can admit to it, there's no shame, no. I remember a couple years back, I went into a health food store looking for vitamin C tablets. And the person who worked there took me to an aisle and they said, all right, here's our vitamin C. We have our synthetic vitamin C. That's not so good. And here's our natural vitamin C. This one actually came from oranges or wherever they took it from. When they said that, what they were saying is that here's the vitamin C that was produced in a laboratory and here's the vitamin C that was produced in a living thing. Is there any difference between a chemical that is produced in a laboratory or one that's been produced in a living thing? No. The answer is absolutely not, okay? As a matter of fact, up until the 1800s, people thought that organic molecules were impossible to synthesize. You know why? Because organic molecules had a life force within them. They actually believed that organic molecules had sort of a soul, and since we could never possibly synthesize that soul, we could never, ever create an organic molecule. And all that was laid to rest when Frederick Wohler decided he was going to synthesize urea from inorganic materials. That was the beginning of organic chemistry. It just so happens that the molecules that we're most interested in will always contain carbon. That's not to say that there isn't carbon in inorganic chemistry. It just means that it's primarily the focus of organic chemistry. Okay, so let's start off with a question. Okay, the question is, why is it that carbon is so special? What's so important about this particular element? Well, it turns out that it's a very versatile element that's capable of producing structures of a very diverse range.